Today we're going to be talking about the rate of change, and so let's go ahead and see what our essential question is. It is, how is slope and the rate of change related? So let's go ahead and talk about what slope is. Again, m is represented by the variable m is going to be representing slope. We can also write slope as rise over run, which is the vertical change over the horizontal change. Okay, and a different way we can say it is the change in y over the change of x, or delta y over delta x. Okay. So for the rate of change, it's going to be a ratio between the change in one variable relative to a corresponding change in another variable. In this case, those variables are going to be, the first variable is going to be our y over our next variable, which is going to be our x. Similar to our slope, because we have y over x, right? So rate of change is going to be how the story changes, and basically rate of change is going to be slope, but in a word problem. So let's go ahead and go to the Pear Deck for today's module, and you'll find these 6 questions. We'll do the first 3 questions together, and then the last 3 questions you'll do by yourself. Okay, so the first question says, suppose the water level of a lake is 35 feet and it is receding at a rate of 1.5 feet per day. Write an equation for the water level L after D days. So here our rate is going to be a few things. So let's go ahead and highlight the numbers that we have. We got that the water level of the lake is 35 feet and that it is receding at a rate of 1.5 feet per day. So here it says that we have a rate of 1.5 feet per day. That's our rate, right? And it even says rate. Our rate is the same as our slope, so that means that that's going to be our slope. But there's a word before that phrase. It says receding, right? So receding is going to be that it's going down. And if it's going down, it's going to be a negative number. So it's not going to be positive 1.5, it's going to be negative 1.5. So for a slope, we can go ahead and put m is equal to negative 1.5. Okay. Our y-intercept is going to be the initial starting point for whatever is happening in our story. And the initial water level of the lake is 35 feet. So our y-intercept, or b, is going to be 35 feet. Okay. So if we put it as an equation, our slope-intercept form, we got y equals mx plus b, right? We would have y equals negative 1.5 x plus 35. But the thing is, in our question, they said that they want water level to be L and D is going to be days. So right now I don't know which one is which. I don't know if Y is going to be the level or the days, and I don't know what X is going to be. I don't know if that's going to be the days or the level. So I'm going to write like a little section. And in our rate, it says feet per day. And so if we write that out as a ratio, feet per day, we can see which one is x and which one is y, right? Because in our slope, we have the change of y over our change of x. So that means our y value is going to be feet, and our x value is going to be our days. So if we look at the letters that they want us to use, the water level is going to be L. And so the water level is going to be feet, which is our new L. And then days is going to be D. So here our y value is going to be water level. Our x value is going to be days. And we're going to use L for y and D for x. So our equation, it's not going to be this because they don't want y and x. They want L and D. So that we can write it as L is equal to negative 1.5 days, D, plus 35. And you read this as the water level is equal to the rate of negative 1.5 days, and we're starting at 35 feet. Okay. Number 2 says Tina babysits after school and charges a flat fee of $3 plus $5 per hour. Write an equation for the cost C after H hours of babysitting. Okay, so let's go ahead and highlight our numbers. It says she charges a flat fee of $3 plus $5 per hour. Right, so our slope is the per hour, because every single time you see per, that's going to be a fraction, and that's going to be our rate. If that's our rate, then that means that that is the same as our slope. So we can write that our slope, M, is equal to $5. There's nothing in the front that says that it's decreasing by $5, so we're going to assume that's positive. The y-intercept is going to be the initial charge, and here she says she charges a flat fee of $3. So our y-intercept, or our b, is going to be 3. So let's write our equation in slope-intercept form. So we got y equals mx plus b. Our m is 5 and our b is 3, right? But they don't want it in that. They want it in this form. The cost is C and the hours is H. Okay, so let's see which one is which. So for our rate, we have $5 per hour. So we have money, or the cost, per hour. Okay. Slope is always the change in y over the change in x, or we can put rise over run. Right. So that means that the cost is going to be our c, so y is going to be c, and our x is going to be our new h. Okay. So let's write our equation with the c and h. So we got the cost is equal to this rate. We got $5 per hour plus a $3 initial fee. And that is our answer. For the last one that we're going to do together, it says the electrician charges $25 for a service call plus $50 per hour of service. Write an equation in slope-intercept form for the cost C after H hours of service. So let's go ahead and highlight what we have. We got a $5 charge for a service call, plus after every hour they charge $50 for his service. Okay, so our rate is going to be right here per, always find per hour of service, $50 per hour of service. So this is our rate, and we said rate is always the same as slope. So our slope, we can say that it is $50. Our y-intercept is what we start with, so we have to call the electrician first, and then he will charge us that $25 first, right? So $25 is going to be our initial fee. And then the equation, we can write it as y equals 50x plus 25, right? But they don't want x and y. They want, what do they want? Cost for C and H of hours of service. Okay, so let's write our rate. Our rate was money per service, because it was the $50 per hour of service. So let's put hour of service. Right. So our money is going to be our y, and our hour of service is going to be our x. So in this case, the cost, or the money, is going to be C. So we're going to replace y with C. And the hours H, our hours of service, is going to be our new X. Oh, sorry, H. So our equation, we can write it as C is equal to 50. We're not going to put X, we're going to put H plus 25. So the cost is equal to $50 per hour plus a $25 initial fee. So you are going to finish questions 4, 5, and 6 on the Pear Deck. And remember, once you exit, it automatically saves and sends it to me.